Hi students, in this class we will discuss few questions from the topic resistance and resistivity. To understand the concepts, please watch video part 4 from the chapter electricity. Question number 1. What are the factors on which the resistance of a conductor depends? We know the resistance expression R is equal to rho L by A, where rho is the resistivity which depends upon the nature of the material. L is the length of the wire or the conductor. It is directly proportional to the length. A is the area of cross section and this resistance is inversely proportional to the area of cross section. The answer for this question is factors on which the resistance of a conductor depends are on length, area of cross section, nature of its material. Resistance is directly proportional to the length and inversely proportional to the area of cross section. R is equal to rho L by A, where rho is the resistivity. Resistivity is different for different materials. Question number 2. How does the resistance of a wire depend on its length? Give a reason for your answer. The resistance expression is R is equal to rho L by A. The resistance R is directly proportional to the length of the conductor. Directly proportional means if L increases, resistance R increases. If L decreases, the resistance R decreases. What will be the reason for this? We have learned about this in part 3 video in the chapter electricity. This resistance R is due to the number of collisions, and for a longer conductor the number of collisions will be more, and for a shorter conductor the number of collisions will be less. Resistance is directly proportional to the length of the wire. The resistance of a wire depends on the number of collisions which the electrons suffer with the fixed positive ions while moving from one end to the other of the conductor. The number of collisions will be more in a longer conductor as compared to a shorter conductor. Therefore, a longer conductor offers more resistance. Third question, how does the resistance of a wire depend on its radius? Explain your answer. We know the expression for resistance R is equal to rho L by A. This expression can also be written as rho L by A, capital A. You can use either small letter A or capital letter A. A represents the area of cross section. A is equal to pi r squared. Therefore, you can write R as R is equal to rho L by pi r squared. In the place of A, we are writing pi r squared, which is the area of cross section. How does the resistance of the wire depend on its radius? Resistance of the wire depends on its radius. From this expression, it is clear that this resistance R is inversely proportional to the square of the radius. What do you mean by inversely proportional? That is, if R increases, this R decreases, and vice versa. If this R is doubled, that means instead of R, if you substitute 2R, 2R the whole squared is 4R squared. If this becomes 4 times, then this R becomes 1/4. Resistance of a wire is inversely proportional to the area of cross section. R is inversely proportional to 1 by A, which is equal to 1 by pi r squared. This means a wire of same length. Same length means we are not altering the length of the conductor, but of double radius is taken. That means R becomes 2 times. Then its resistance will become 1/4. Question number 4. If length of a resistance wire becomes half and cross-section area becomes twice, then find the relation between old resistance and new resistance. The expression for resistance is R is equal to rho L by A. Here R dash is equal to rho into length of a resistance wire becomes half. Therefore, in this place of length L, we must put L by 2 so that the length becomes half, divided by area of cross section. Cross section area becomes twice. A becomes 2A. R dash is equal to rho L by 2 divided by 2A, which is equal to rho L by 4A. What is R dash divided by R? R dash is equal to rho L divided by 4A. R is rho L by A, which is equal to rho L divided by 4A into rho L. And this A goes to the numerator, rho L into A. A and A cancels, rho L and rho L you can cancel, which is equal to 1 by 4. If R dash by R is equal to 1 by 4, 4R dash is equal to R when you cross multiply. That means the new resistance R dash is equal to R by 4. The answer for this question is, first write down for the old resistance expression, then for new resistance R dash, divide those two equations, then you will get R dash as R by 4. That means resistance becomes 1/4. Question number 5. How does the resistance of a metallic wire depend on its temperature? Explain with reason. From the expression R is equal to rho L by A, can you answer this question? How does the resistance of a metallic wire depend on its temperature? No, you cannot, because there is no temperature in this expression. Please remember that the resistance is directly proportional to the temperature. That means if temperature increases, resistance also increases. Now we need to explain this with a reason. Say you have a metallic wire or a conductor. When temperature is increased to this conductor, the atoms inside this conductor will start vibrating with greater amplitude. Due to the increase in temperature, the thermal velocity of these electrons will become higher. The molecules moving in random velocities with much higher velocities will result in large number of collisions. Also, the fixed positive ions will also start to vibrate about their main position. All these will result in large number of collisions, and hence the resistance will increase. The resistance increases as the temperature of a metallic conductor increases, so the resistance is directly proportional to temperature. How will you explain this? With the increase in temperature of the conductor, both the random motion of the electrons and the amplitude of vibration of fixed positive ions increases. As a result, the number of collisions increases. Hence, the resistance of the conductor increases with the increase in its temperature. The resistance of filament of bulb is more when it is glowing, that is when it is at a higher temperature, as compared to when it is not glowing, that is when it is cold. Higher temperature means higher resistance. Sixth question, differentiate between resistance and resistivity. You have to differentiate between resistance and resistivity. What is a resistance? Resistance is the opposition provided by the atoms of a conductor to the flow of electrons. That is the definition for resistance. Second point, you can write the unit. What is the SI unit of resistance? SI unit of resistance is ohm. We also know the resistance depends on length, area of cross section, material and temperature of the conductor. What is resistivity? Resistivity is the resistance of the conductor. It is resistance. Resistivity is nothing but it is the resistance of the conductor of that substance of unit length and unit area of cross section. That is resistivity. What is the SI unit of resistivity? SI unit of resistivity is ohm meter. Ohm meter. Resistivity of the substance depends only on the material of the substance. We have already learned that the different materials will have different resistivity. Question number 7. Two wires, one of copper and other of iron, are of the same length and same radius. Which will have more resistance? Give reason. You have two wires. One wire is made up of copper and the other wire is made up of iron. Both these wires have the same length and same radius. Which will have more resistance? We know the expression R is equal to rho L by A. They have the same length and same radius. Therefore, the resistance now depends on the resistivity rho of the material. You must know what is the resistivity rho for copper and the resistivity for iron. Which is having more resistivity, iron or copper? The resistivity rho for iron is higher than that of copper. Therefore, if the resistivity rho is greater for iron, the resistance R will be more for the iron. Greater the resistivity, greater will be the resistance. Therefore, the answer is iron has more resistivity as compared to copper. So, greater the resistivity, the more the resistance is, and smaller the resistivity, the lesser the resistance. Hence, iron wire has more resistance than copper wire of the same length and same radius. Remember, iron has more resistivity as compared to copper. Next question, question number 8. What are resistors? Give some examples. Substances having comparatively high electrical resistance are called resistors. Resistors are substances having comparatively high electrical resistance. For resistors, you should choose substances which is having high electrical resistance. Give some examples. Some examples for resistors are alloys like nichrome, manganese, constantan, etc. Question number 9. If a wire is increased to 4 times its original length, by what factor does the resistivity change? In the question, they are asking by what factor does the resistivity change? Will the resistivity change when the wire is increased to 4 times its original length? No, we know the resistivity depends only on the nature of the material. The answer is, since the resistivity depends only on the material of the wire and not its length, it will remain the same. Question number 10. Name a material which is used for making the standard resistor. Give a reason for your answer. Manganese is used for making the standard resistor because its resistivity is quite large and the effect of change in temperature on their resistance is negligible. You must learn this material name. Manganese is used for making the standard resistor. Reason is because its resistivity is quite large. We learned about resistivity. The resistivity of this particular material magnet is quite large, and also the effect of change in temperature on their resistance is negligible. Therefore, you can choose this material for making the standard resistor. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.